So question 23 says solve the equation in the complex number system. So again, as a hint, complex number system is probably telling us to solve this quadratic equation using the quadratic formula. So again, the formula's got to be, the equation's got to be the form of ax squared plus bx plus c is equal to 0. It has to be set equal to 0. We have x equals in the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So in our problem, the coefficient of x squared is 1, so a equals 1. The coefficient of the linear term, the coefficient of the x, is also 1, so b should equal 1. And then the constant is the 2, so c would equal 2. So the numbers don't look all that big, so let's see what we got here. So x is going to equal the opposite of b, so the opposite of 1 is -1, plus or minus the square root of, and then 1 squared is just 1, minus 10. So we have 4 times a times c. So that's 4 times 1, which is 4 times 2 is 8. That's going to be -8 then. Then it's going to be over 2 times 1 is 2. So we then have x equals -1 plus or minus, and then 1 minus 8 will be a -7. And then that would be over 2. Notice that since there's a negative inside the radical, that means an I is going to come out. This is going to represent imaginary value. So that's going to be I square root of 7. The square root of 7 is a prime number, so it does not have any factor pairs, so that stays put. So that would be our answer. We can also write this as -1 over 2 plus or minus I squared of 7 over 2, separate it. And also that neither answer can be simplified. The 2 does not go to anything in the numerators, so that would be reduced. So the two solutions would be -1/2 plus I squared of 7 over 2. This would be our solution set. And then -1/2 minus I squared of 7 over 2. That would be our two imaginary or complex numbers, if you will, for that.